Welcome back to 3 Inquisitive Kids. My name is Karen, one of the recorders on this channel. And in this lesson, we're starting a brand new chapter where we're going to be talking all about inequalities. So let's dive right in. Introduction to inequalities. Understand unequal relationships between quantities. I'm sure inequalities are something that you might have heard a little bit of, but you're not totally sure what it is. Well, today we're going to discover the definition of the inequality, and we're going to solve some basic inequality problems to get your brain warmed up for this chapter. Again, this is the first lesson in our Unit 9 of 8th grade math. So as you can see, we're going to have properties of inequalities, solution sets of inequalities, and so much more. The learning goals of today is to understand the concept of inequalities and recognize the meaning of the inequality signs, and to learn and accurately use inequalities to represent quantitative relationships and form the idea of permitting the combination of numbers and shapes in expressions. Here is our introduction. In real life, there are unequal and equal relationships between quantities. For unequal relationships, how do we express them with formulas? For example, Kanban's height is 155 centimeters, and Karen's height is 156 centimeters, as you can see here. In this case, we can use the inequality signs greater than or less than to express the relationship between these two numbers. Greater than and less than is something that you've probably encountered before, right? When you were just starting with your math career, probably early in elementary school, you learn how to compare numbers. Maybe later on you learn how to compare bigger numbers or fractions. And the greater than or less than symbol were probably the symbols that you used when comparing. So the expression we can use to describe this scenario would be 156 is greater than 155, or 155 is less than 156. Expressing relationships using inequalities. As shown, a 50-gram heavy weight is placed on the right side of a balance. A ball is placed on the left side of the balance, causing it to tip leftward. What is the relationship between the weight of the ball and the weight? Can you use the earlier example to help yourself answer this question? Well, we can answer in two ways. One using the greater than symbol, the other one using the less than symbol. So we can either say x is greater than 50, since the balance leans towards the ball, or we can say 50 is less than x. Here's another question. A car is driving on a highway with a minimum speed of 60 kilometers per hour and a speed limit of 100 kilometers per hour. How can you use an expression to describe the relationship between the distance traveled, s, in kilometers, and the traveled time, x, in hours? Well, here's the answer. The quantitative relationship would be s is greater than 60x and s is less than 100x. There are actually two quantitative relationships in this question because it has a minimum speed and a maximum speed. And another way you could write this is to connect these two together. Since the variable s is used in both of these expressions, you can link them together by saying x is greater than 60x, and at the same time, it is less than 100x. Here we're making a range for s. S is valid as long as it is anywhere in between 60 and 100. Question 3. The railway department has the following regulations on carry-on luggage. The sum of the length, width, and height of each piece of luggage shall not exceed 160 centimeters. Let the length, width, and height of the luggage be A centimeters, B centimeters, and C centimeters respectively. Please write an expression that shows values for the length, width, and height of the luggage that satisfy the requirements. Again, pause the video and answer this question on your own first. The expression would be A plus B plus C is less than or equal to 160 centimeters. Here the keyword is shall not exceed. It's very important when looking at problems like this to really find what our keyword is. You might say less than 160 centimeters, and if you did, that would be wrong, because shall not exceed and less than are different things. Shall not exceed, it means that it's just not greater than 160 centimeters. It means also that it could be equal to 160 centimeters. That means that this would be the correct answer. And the symbol right here, a less than symbol with a horizontal line underneath it, is the less than or equal to symbol. Again, this is the less than or equal to symbol. The other way we can think about it is if you see the greater sign followed by a horizontal line or a line like that, it would be the greater than or equal to symbol. Observe the expressions from the previous problems. 156 is greater than 155, 155 is less than 156, x is greater than 50, s is greater than 60x, s is less than 100x, a plus b plus c is less than or equal to 160. What feature do these expressions all share? The feature that they all share is that the left and right sides of the expressions are all inequivalent. So here's our conclusion. When expressions including inequality signs, such as greater than or equal to, and less than or equal to, these expressions are called inequalities. Let's do some practice. Determine whether or not the following expressions are inequalities. Let's look at this first one right here. -3 is greater than 0. Well, is -3 greater than 0? It's not. It's just not true, which means that this first one is not an inequality. The second one, 4x plus 3y is less than 0. This is an inequality. On one side, it has an expression, and on the other side, it has an expression. And the sign is an unequal sign. The next one is x is equal to 3. Well, there's an equal sign here, so it cannot be an inequality. X squared plus xy plus y squared has no sign in it at all. It is just an expression. But it is not an inequality because it has only one side, which means that 4 is not an inequality. And for the last one, this would be an inequality. As shown, two ropes each with a length of L centimeters create the perimeter of a square and a circle. If the area of the square does not exceed 25 centimeters squared, what conditions should L satisfy? And 2. If the area of the circle doesn't go below 100 centimeters squared, what conditions should L satisfy? Pause the video and answer these questions on your own. The answer to the first question would be L squared over 16 is less than or equal to 25. Again, the keyword is doesn't exceed, not less than. And the answer to the next question would be L squared over 4 pi is greater than or equal to 100. Again, the keyword is doesn't go below. When L is equal to 8, which shape, the square or the circle, has the bigger area? What if L is equal to 12? Well, all you have to do is substitute these given values into the area formulas of the square and the circle. When L is equal to 8, the area of the square would be 4, and the area of the circle would be about 5.1. So L squared over 4 pi is greater than L squared is over 16. When L is equal to 12, the area of the square is 9, and the area of the circle is about 11.5, which means that in this case, the area of the circle is still greater than the area of the square. When L is equal to 40, what shape has the larger area? Through the previous problems, what can you conclude? Well, still the same steps. When L is equal to 40, the area of the square is 100, and the area of the circle is about 127.4. And the area of the circle is still greater than that of the square. So we can conclude that no matter what the length of L is, the circle is always going to have the greater area than the square. Let's do some more exercise with this concept. Express the following relations with inequalities and write down the two numbers that satisfy the inequalities. All right, so let's look at to this first one, we have half of x is not less than -1. Half of x is one expression and -1 is another. Not less than is the key word here. The inequality would be 0.5x is greater than or equal to -1. X can be -1 or 1 in order for this to be true. The sum of y and 4 is greater than 0.5. So this would be the answer, and y can be equal to 0 or 1. A is negative. If A is negative, A is less than 0. A can be -3, -4. B is not negative. Well, since B is non-negative, it can be either positive or 0, which means that B can be equal to 0 or 2. B is greater than 0 or B is equal to 0. So something else we can write is B is greater than or equal to 0. That's just combining both of these expressions in one. Class summary. Today we had our introduction to inequalities, where we learned about its concept, which was expressions containing greater than or less than symbols, and expressing relationships between quantities. First, we have to understand the key words, then find the quantities, and then finally we write the inequality. Again, these are our two learning skills of today. We understood the concept of inequalities and recognized the meaning of the inequality sign. We also learned and were accurately able to use inequalities to represent quantitative relationships and form the idea of permitting the combination of numbers and shapes in expressions. So thank you so much for watching through Inquisitive Kids. If you enjoyed this video, please hit the like button. And if you would like to be notified for more of these, be sure to smack that subscribe button as well. Again, thank you so much for watching this channel, and we'll see you next time.